And I say, got it. There we are. Thank you. Right. Thank you very much for inviting me to give this talk. And I need to give you a little bit of background as to how I came to be doing it, and also to explain what it means to have these strange things on the bottom of the screen, CDIS and University of Cambridge Institute for Manufacturing. And I hope that will become clear in the next few minutes. My involvement in this sort of subject started as one of the many things that our late Martin Edmonds very much missed, very much respected, and a member of LMHG. He actually fixed me up with all manner of interesting assignments over the years that I knew him in Lancaster. And what I'm going to talk about tonight is one of those. He actually, when he was at Lancaster, he worked in the politics department. And while he was there, he started this group called CDIS, the Center for Defense and International Security Studies. And it was really quite a prestigious group because Martin had many contacts at a high level in the military and in government circles. And so he was able to pull in some very, very good speakers to work with this group and to address meetings and so forth. Now, actually, Martin and I both went to the same school. It was actually Oundle. I've actually got the tie on just for now. And but he was about 4 years older than I am, and you know, an 18-year-old regarded somebody who's 13 years old as a sort of barely human subspecies. So there was never any interaction. I didn't really know him at all, or even spoke to him all that time. But our paths crossed much later on, as you will see shortly. Now, as I say, Martin got me involved when I got to Lancaster. I'm really a sort of industrial academic with industrial experience and employment in, well, two companies in particular, Rolls-Royce Shrewsbury, that interestingly made the engines which eventually were for the Shah-Iran tank and became the engine for the Challenger, a very powerful 1200 horsepower, 12-cylinder V engine. And also I then worked for ICI, AstraZeneca, as it became, as a division machinery engineer. So I was really very involved in practical engineering and also the design and selection of engineering systems. So that's my background. But I was conned, yeah, I suppose so, into coming to Lancaster University to run the northern half of a rather prestigious Cambridge University postgrad course called the Advanced Course in Design, Manufacture and Management. And this was designed by a rather charismatic chap called Mike Sharman, who many of the mainline academics regarded a bit snootily. But he almost made out that until postgrads had been through his hands, they weren't much use to industry. There was some, I think, truth in that. And I basically became his northern outpost, responsible for everything that went on, fixing small projects, large projects, and visits and all manner of interactions with industry in an area from Birmingham way up into the industrial heart of Scotland. And everything else was in the Cambridge ambit. And then another chap came along to work with us called Mike Gregory, who came from industry and turned himself into an academic. And eventually, because of some excellent work he was doing with the British government, he got his CBE. And I knew him well enough to send him an email saying, Mike, well done, old chap, but it's not good enough, try harder. And 4 years later, he was Sir Mike Gregory. So I had some good connections there. Meanwhile, Andy Shaw came on the scene, and he was, I think he was a Lancaster graduate originally, and he did a physics degree, but actually his employment, his main employment eventually was at VSEL, Vickers Shipbuilding and Engineering Limited, you remember, that got, I suppose, taken over eaten by BAE Systems. And he actually went on SEAL trials in submarines. That was his job. And he also was involved in the concept design of the British Terrier combat engineering tractor, and also the AS-90 self-propelled 155mm gun, which some of you no doubt will be familiar with. So we've had a pretty varied background. So I thought I'd give you a bit of that to begin with, so you could see where we're coming from and why these strange things are on the bottom of most of the slides. But for proprietary reasons, I've taken them off the next few. So I'll now proceed with the main part of the presentation. So if you take your mind back to around about the late 80s, 89 and so forth, we had our friend Mikhail Gorbachev came onto the scene. And I actually have his book here, Perestroika, was given it as a Christmas present. Not exactly bedtime reading, but quite interesting. And also I have a habit sometimes of stuffing interesting newspaper articles from newspapers like the Old Independent and this one, 1989. And there's Gorby. He actually addressed the Guildhall, big audience, and outlined what his plans were for the then Soviet Union. And this was a very, very interesting period. Now, I think Ronald Reagan, when he came into power, he was a bit suspicious of what was going on with Gorbachev. But Maggie Thatcher had already had some dealings with Gorbachev. And I think she famously said that she recognized here was a man that with whom we could do business. Am I correct? Yes, I think I probably am in saying that. So that's what happened. There was then, of course, the Yeltsin period. And Gorbachev, I suppose, had presided over the Soviet Union, which was really an economic basket case. The arms race was ruinous to the Soviet Union. It realized it couldn't compete with the power of the West, in particular the United States. So we got old Yeltsin here, who was having a good chat with Jimmy Carter. What Carter's laughing at, I don't know. But Yeltsin, of course, was alcoholic, sadly. But he did have his moment of courage when he stood on the steps of the White House in Moscow and basically called out the guys, and called off, I should say, the guys who wanted to foment a counter-revolution. And when I was in Moscow myself, on a rather intriguing trip, again, through Martin Edmonds, I actually saw myself, it was so recent, this affair, that the smoke marks and damage was still visible on the face of the building. And that was a bit of a close call, because of course, when you start to lift the lid on a kind of boiling pot, as Russia was, then if you're not careful, stuff goes everywhere, and it did. So there were times, I think, of optimism. So we had some key treaties, two, which I'll mention. If you want to know more about these, it's absolutely all over Wikipedia. You can, of course, find more authoritative papers and whatnots if you decide to have a look. But we had START 1, Strategic Arms Reduction Treaty between the USA and the Soviet Union. And you can see there the key dates. And it finished in 2009. And then we had this new one, which is still, after many, let's say, fits and starts, still ongoing with provisions to 2025. And it did have an effect, or has had an effect over the years, of reducing this enormous preponderance of nuclear armed missiles of all manner of sorts, including especially the so-called heavy Russian ones, very large megatonnage, back to probably about less than a third or maybe even a quarter of what there used to be at peak. And of course, the weapons we're now talking about are far more precise in their targeting, but generally smaller. So there has been some beneficial effect there. And when the Russians decided to be serious about reducing some of their strategic arms, probably the older stuff and the bigger warheads, they didn't know what to do with the fissile material, but the Americans did. And so there was an arrangement whereby a lot of fissile material was actually sent from the Soviet Union to the USA for reprocessing. And quite a lot of it ended up actually in US nuclear reactors, one extraordinary thought. While this was going on, or close to that, we also had a treaty which had some effect on what I want to talk about mostly this evening. And that's the CFE Treaty, Conventional Forces Europe Reduction Treaty, which was basically about all the other heavy stuff, non-nuclear stuff, main battle tanks, APCs, artillery pieces, and so forth. And it was signed by 22 states in 1990, but by then, of course, the Soviet Union began to realize that it was a bit time limited. Now, do you really trust Russians? I wouldn't like to say, but I think they decided to try and send a lot of their stuff where nobody would notice. So they burned a lot of it by train out a long way off to places that ended in Stan, as we shall see. And so it was signed by 22 states in 1990 and ratified by 30 states in 1991. Why? Because we generated so many new states, or states that had been released, if you will, from the grip of the former Soviet Union. So that's where the stuff ended up. And now I really get down to business, talking about how we got involved. So you know a bit about us already. And I'm acknowledging Andy Shaw's contribution because he's not here tonight to make it, but he's going to have a look at this to see what bad things I've said when he gets it on YouTube. And it was organized by NATO, funded by NATO, and organized through largely through Shrivenham and a chap called Mike Young, who lives in Cumbria, or did. And we had a few publications about it. But more particularly, we had two meetings, a small group of about 16 people from various countries in Bratislava later on. So, and that was in 2004, 2005. So what we're dealing with, what are we dealing with? And I'll kick off with my bit. And essentially, it's the East Asian republics where most of this heavy weaponry now or then resides, and probably most of it still does. So where are these places? Well, you probably know a lot, as much as I do. Not that I've actually personally been to any, or not yet, but Kazakhstan is the biggest, and then you've got all these others. And down here is Afghanistan, which is not actually mentioned here. Of course, there was a lot of military equipment in Afghanistan, but it was left by the Russians, mostly in a state that doesn't really go very well, if at all. In other words, tanks and so on that have brewed up and been left as wreckage in the landscape. So a lot of the tanks we understood from people like Mike Young. He'd been to Almaty in Kazakhstan to do a bit of path finding. There are about 5,000 tanks at least sitting in various parks, tank parks in Kazakhstan. They got there by rail and been pushed off and left. So 5 East Asian states have got these things. Biggest one is Kazakhstan. And this is quite a bit about these states. They've all got serious problems, as you can see on this slide, various sorts. They're not friendly with each other. Some of them are actually stuck to ex-Soviet doctrine, like the Ghastly people guy in Uzbekistan, I think. Someone might correct me on that one. And they all have quantities of redundant or incapable heavy weapons. Now, anybody who sort of wants to get involved in any sort of way with places that end in stand have got to know what they're doing, maybe rather better than, have a better understanding maybe than some of our present, dare I say, government people have. And you can see there, this is a slide that I produced after sort of thinking about it rather. The sort of essential differences. I actually come down straight to this one at the bottom, what I call transcendent belief systems in the West decay. I've said it's a decaying, a residual ethical framework derived from our Western Judeo-Christian heritage. and in many countries, particularly places like Sweden, it's most definitely on the way out. And then on the other side, you've got community codes, creeds, and transcendent beliefs, which are very strong, even though there are many divisions, for example, within Islam, as we know only too well, not just the Sunni Shia divide, but many others as well. So whereas we're in a very dynamic and changing situation, the rate of change in these places is a lot less. But we have to understand what we might be going into when we try and take away their, dare I say, toys, because some of these, you know, you've got 5,000 tanks sitting in a park. Maybe if it don't work anymore, they still might mean something to you if you're some of the senior people in that place. So have to be aware of this, you know, reviving the clash of civilizations. Remember the Huntington's thesis about the chaps trying to get in over the wall between the Crusaders and the Islamic people. And also maybe I ought to take a bit notice as to what happened in South Africa to begin with when Desmond Tutu was basically a sort of moral tutor, I suppose, to our late friend Nelson Mandela. So, you know, I have to think about some of these things, as I do quite a bit. So we got busy on these little working parties or workshops, as people call them these days. Workshop to means a place with machinery and the smell of cutting fluid, as I'm very familiar with. But somebody said, I think it was a very good statement, you can't solve the wars in Africa until you've solved the arms problem in Central Asia. Because all this stuff, particularly the small arms, I think that's probably an underestimate. 300 million AK-47s have been manufactured, and you see them all over the place in the hands of terrorists and people you really wouldn't want to meet on a dark night. And then there's a lot else, as you see here. So you've got ammunition of all sorts. You've got these sorts of things lying about, and without too much effort, you can convert, you know, a tank shell with a normal industrial detonator into a booby trap, particularly if you know, put it in a culvert somewhere, as happened a lot in Afghanistan, actually. And these are just various different types of armor piercing or squash head tank shell. So now there's a lot of expertise in the former Soviet republics, like these countries here. And I got a lot of slides actually during the workshops in Bratislava from various people who were there. And this is basically a line that was used for pressing charges for high explosive anti-tank munitions. And that's an interesting section of an anti-tank missile head. I should emphasize on this slide that the direction in which it is flying to the target is from top to down here. You see here, I think some of you will know what this actually is. This is a copper cone around which is packed high explosive. And when this hits a target, the cone kind of collapses. And as the apex sort of gets pushed this way, all this copper or copper alloy goes into a hypersonic jet, which is quite small in diameter. And this will burn its way through 400 millimeters or more of armor plate, leaving a very small hole. Now, I don't know whether you can see this on my slide here. If you've still got me on there, you can hardly see a hole there, but it's only about 1/4 of an inch diameter. And that's where the jet of molten copper would go through into the interior of a vehicle. If you happen to be in the vehicle, it won't be very nice. And Andy Shaw and I actually went on a short course at Shrivenham with a few other people, odd sorts of people from BBC monitoring and so forth. And we had a wonderful time playing with AK-47s and other sorts of weapons on their small 25-yard range. And we also went on the explosives range, and we were given the bottom, the conical part cut off to make a kind of cut at the bottom of a wine glass. And with the aid of Semtex, which I happily packed around the bottom of this wine glass, we actually sent it through about 6 of these steel plates. And there's the hole. That's my party piece. Scary stuff. So as well as having the expertise in manufacturing these things, then also in Slovakia, they have created expertise in actually dismantling artillery shells. And this is just a little diagram of a machine that for doing it. And that's a photograph, an actual one. And this particular machine, obviously you need many machines to do this sort of thing. This one is actually pulling the projectile out of the casing. You have to do that obviously before you can get at what's inside. So they did all this sort of thing in Slovakia on quite a large scale. And here also in the Czech Republic, Colonel Engineer Jan Milas was running a group for rebuilding tanks or parts of tanks, the chassis and bottom of tanks as special purpose vehicles. This is one of the things we were thinking about. And getting rid of what was not needed and developing know-how on to deal with former Soviet tanks like T-55, T-72, and indeed upwards. And over in our little working group, our remit was to concentrate on tanks. Others elsewhere dealt with all this sort of stuff. So here we are then, typical T-72. A lot of this equipment ended up in the UK because at that time you could get it for, people wanted it for museums like Bovington Tank Museum or Norfolk Tank Museum or Duxford even, which is where I took these particular photos. Before you can do anything with something like a tank, you've got to make sure that dangerous things are taken away and dealt with elsewhere. And this is, I think many of you tonight will know about these. This is the so-called explosive reactive armor, which is a sandwich of high explosive in between steel plates. And the idea is that when the missile hits these, then this little brick, as it were, explodes and again in microseconds and destroys the missile head before it can penetrate the armor within. Of course, once you've fired a few of these off, if you have today's tandem munitions, the second warhead will come and look for the vacant space and Bob's your uncle or not. So that's the sort of thing you have to do. And a lot of other things came over as well. If you remember in Lancaster, we had, what do we call that storm in 2016, Desmond, when we had to search the whole country for mobile generator sets to keep Lancaster going because we had one substation which got flooded. Whereas Exeter, I talked to some of the people who were running these things, and Exeter, they told me, had 6 substations around the city in a ring. So if they'd got flooded, you know, they wouldn't have had the problem we did. So we were thinking about mobile workshops, but also gensets. This happens to be a genset. That's Andy Shaw looking at one. And this is what you might find inside. Diesel engine, generator, and all the instrumentation could be ready to go. Who knows? So we came to the conclusion a lot of this equipment could be adapted to civilian use, provided that all these things. And this one this third one is particularly important because you would need to know about how it was manufactured, what it was made of before you can do anything. So if you look at a tank, you know, you could say that broadly, if I divide this sort of screen, oops, where's my little pointer? To divide it sort of vertically and say everything on the left over here is fighting equipment, and that's not what you really want if you're going to use it for civilian use. You've got the structure and protection. Some of that might be, well, you don't want explosive armor, you don't want applique armor, or you probably don't want anti-radiation shielding. But on the other side, you know, you've got the base of the tank, its structure, engine group, transmissions, wheels, tracks, all that lot. And hydraulic and electric power. And a lot of this is what you think, you know, you could use for something else and put civilian add-ons on it. Or if you're lucky, you might even find yourself with a combat engineering tractor, which has got most of these things on, like a crane, a bulldozer, a winch, a fire monitor, and so forth. So we were sort of looking at it in this side of the diagram, if you will. But the question also always is, how the hell do we get the thing like this working if you've got no information? You know, you've opened up a lid and you see that, and what do you do with it? And, you know, we quickly realized that a superficial view, not a lot of use. That's me inside a Russian, it's a Duxford BMP 8-wheel armored personnel carrier. That's Andy with his head sticking out of the other end. Crikey, I mean, frankly, I wouldn't want to be a Russian sitting in one of these things if it was hit by a, you know, munition, because how you get out of this in a hurry, I have absolutely no idea. Very dreadful. But yeah, we need detailed engagement to find out how to civilianize a tank. We need people who knew what they were talking about. And you need to be able to deal with all these systems linked, mechanical, electrical, hydraulic, and appropriate. But now, incidentally, I just mentioned this, I got involved with a little team at Lancaster in looking at the preliminary specification under some confidentiality, I have to say, for the British Army Terrier, which is now in service, combat engineering tractor. Because I was a bit of a hydraulics guru, I actually designed some circuits. Whether these were actually used, I couldn't say. There's nothing confidential about that, because it's just bog standard hydraulics, which any hydraulics engineer would know about. So it really boils down to this: the information in the product life cycle. The further in time you get from manufacture, where you know lots about it, the product you've got, the further away you get, the less you know. So I think this is based on this little diagram, not one of mine really. It's based around ideas like a washing machine. You know, you think of a 15-year-old washing machine, you want to get somebody to repair it. You have a hell of a job because you're out here somewhere. You know, no parts availability. What do? It's, well, recycle it into bits, put it in a skip. Lancaster's pretty good at this sort of thing, you know. So these are things we have to think about. The logistics, getting these things to the destinations, risk assessments, custom, trans-border clearance issues, routes and networks for internal distribution in states. How do you do it? Markets and methods. So we reckoned that we could look at all these things. Military refurbished, not really where I wanted to go. Major units, self-mobile, civil use, question mark, subcomponents for civil market. Amazing what people could collect. When I was in Moscow with that BAE trip, it was amazing what you'd find in street markets. You could buy a general's uniform. The most I ever got was a Russian hat with a you know, with a badge on it. But yes, you could buy gun sights, all sorts of interesting things, really interesting stuff. And of course, scrap you could do. So we had all the ideas, well, all the way from do nothing, just leave it to rot, you know, find it, go and shove it in the sea somewhere. Not a good idea. All this sort of thing. Give away to emergency agencies and what they would do with it. The sell complete, design for museums. We've got loads of these things, or cut up for scrap and other uses we haven't thought of. So a bit more detail. MACP, non-lethal riot control, water and high expansion foam projection. Good for riots. I had a student working on this for quite a while, actually. Quite interesting. Oil well fighting. Wait. I'm going to tell you a bit more about this. And then just use some of the components for static things like this, you see, all this sort of stuff. So what do? Recover it, batteries, fuel, oils, plastics, giveaway for people like this, Minds Advisory Group, so on and so forth. Sell to Hollywood, Bollywood, theme parks, museums, private collectors. There are quite a few of those little aluminium tanks in the UK that people have bought. What do you call, not scimitar? Was that right? No, something else. Forgotten the name of it. Powered by a Jaguar engine. Now we get down to a really interesting application, which I thought you'd be amused to hear about. Oh gosh, that's a bit premature. Why did that come up? This Colonel Engineer Joseph Spikes, Hungarian, I actually met him at the one of the workshops, and I said I'd heard that there were some crazy Hungarian guys who, when Saddam Hussein's people set all the wellheads on fire, 700 wellheads on fire after the invasion of Kuwait, we're left with all these burning wellheads. Fortunately, a lot of the Christmas trees, you can see one on the right there, the lower diagram, was still there. So if you could get at it, you could turn it off. But first of all, you've got to put the flame out. So Colonel Spikes and his gang, they had this brilliant idea of creating a massive inert gas generator with a powerful puff. And they put 2 MiG-21 engines on the back of a tank chassis. And with this, they simply advanced against the flaming wellhead and puffed them out, leaving simply a great plume of gas, pretty dodgy really, for really brave people to go and turn off the tap, or in a very few cases use the sort of techniques that the Americans like Red Adair have used to blow out flames and then bolt things onto broken wellheads to turn it off. So that was all good fun. But we concluded, sadly, that the market for civil conversions is actually very small in relation to the number of redundant tanks, and the most viable route is to scrap them in view of rising world scrap prices. So we looked at all the things that we saw in an armoured fighting vehicle at Duxford, and you could see all this stuff. We looked at it, thought, well, there's all these things which we could turn into scrap metal. Consider the tank, obviously some very high alloys in things like the turret, and if you want to basically process this, you've got to melt it somehow, and the way to do it is in an electric arc furnace. But once you've got going, it's like mixing a Christmas cake. You can't extract the constituents. You can only end up with a mixture. So you would dilute it, use it to light with, dilute it with lower grade scrap. And then when you do this, of course, you're now pulling a tank to bits. You've got a lot of potential hazard in there. People have been killed, sadly not recently in the UK, when they tried to cut up oil drums thinking they were empty. Bit of an oil residue in there, you get at it with your oxyacetylene torch, cut into it and away, bang, and that's that. Battery acids are very dangerous. A friend of mine, I have to say, he was a bit impractical, I won't mention his name. He was charging his car battery and made the dangerous error of disconnecting it at the battery terminals before he'd switched off at the mains. There was a spark, and of course, when you get a fully charged battery, it electrolyzes the acid, and you get oxygen at one terminal and hydrogen at the other, coming out together, and then you get a spark and kapow. Well, he blew the top off the battery, and he was very fortunate not to get sprayed with acid. And people have lost their sight doing precisely that. Not that often, but over the years there have been accidents of that sort. So one had to realise what one was doing. Now, the UK MOD had an experiment to reduce a T-55 tank to scrap. And I won't bother to go through in detail, but they essentially did all this. After having checked it, they chopped it up using a torch and in sequence and in a logical way. And eventually they were able to put the bits into 20-ton skips, or a 20-ton skip. That's how they did it. And this is what they did. And they learned all sorts of tricks in doing it. One of the most important was never run out of gas. Avoid cutting through paint. And obviously, don't cut into oil or fuel tanks, even if you think they're empty. And know where there's anything hazardous, asbestos and so forth. So all that was, part of our sort of model. And then you need access to a steelworks. And actually in Kazakhstan, that would not be a problem because of the fact of the existing rail network. What you need is able to melt and cast scrap to ingot or concast. That's continuous casting for making sections, as you see a bar sections, plate and sheet. And there you are, electric arc furnace, ginormous kettle, probably about 8 or 9 meters diameter, carbon electrodes, each the diameter. And I've seen these things working, pretty terrifying things really. The carbon electrodes are about 8 inches diameter, 200 mil diameter each. They come down onto the scrap and massive spark, colossal current of tens of thousands of amps. Nearest one to us is at Stocksbridge near Sheffield, where they do this. Then this thing's on trunnions, so you can tip it out like a kettle. Everything goes in that door out this door, slag first, and then the molten metal into an ingot mold. Brilliant. Only way to do it, really. Now here we are, then looking at some destruction operations in Macedonia. These are the Hungarians chopping up tanks, and this is the sort of stuff that would go to the steelworks for melting down. Some things, I think they reckon they were too hazardous to do that with, and they basically buried them deep. And they did a lot. As you see here, over 92 to 2004, they did at the end of 2000 MBTs, main battle tanks, APCs, and artillery pieces. And it was ongoing at the time we were doing the workshops. That was quite impressive. That was the Hungarians doing that. So then old Andy got busy. This is where I go a bit quicker because we end up with less pretty pictures on this part, but it ends up with a bit of maths, which I'm not deploying. So he did that. He knows more about modeling systems than I ever did. So we looked at logistics for doing this in detail. Well, a lot of this was supposition, really. What we would need to do all this, lifting equipment, for example, and people who know how to handle it. And where do you get all these people from? So security, border protocols, a lot of interesting things there. So he went about presenting this. We did a presentation on all this. With these are the main stages in it. And the idea was we wanted to look at the overall economics. Would it be attractive to do it? And based on relatively inadequate information. Think of the difficulty we have in understanding, going on with COVID at the moment. To make mathematical models is no easy job. So a model based on a process, which is fairly well understood, but you have some basic assumptions, get some numbers, make an estimate as best we can, and let the model itself, the algorithm, if you will, let that generate some potential financial outcomes we can look at. And basic assumptions, Kazakhstan, 5,000 vehicles, similar type. All this, it can be moved or towed to our businesses. Ammunition and the nasty stuff has been removed. And from the Czech side and also the MOD in the UK, had some ideas of how long it would take to dismantle a tank. Quite a lot of effort. 40 man-hours cutting. And you think of the amount of gas you're going to have to use to do that on these big, thick sections. 5-year program. And then how long the resources that would be required, 50-hour week. How many men, we have to say here, to do this job. So, and we need a train with 40 wagons, 50 tons per wagon, each tank to generate 25 tons of scrap. And on we go, see how we do it. Teams of 40 working on 5 vehicles at any one time. All this. Segregation of scrap as far as we could. Ferrous, aluminium, alloy, lead, copper, and other. And each team thinking how you do it. Cross-training, we'd have to train the slinging. That doesn't mean like David and Goliath. It means how you hang stuff from cranes using chains or straps in the best way. Even after somebody would have to consider how you pay these people, where you get them from. And then we have the process. Well, you see that thing goes basically. Imagine now a line of these tanks, loads and loads of them behind us, lots and lots of them. And you're now going to send these being forward into something where a team of 40 operatives work on 5 vehicles at any one time. Start with inspection, record hazards, tag it, safety issues, and so on. Radioactive stuff removed, and off we go. You see the sort of loop taking place here. The action is going around in a circle. So row of tanks, you start pushing them forward, and all these 5 being worked on simultaneously. There it is, nothing's been done. Oh, the turret's off. Turret's gone, turret's separated. You've just got a hull, turret's away somewhere, finished cutting, and it's off. And then the next one starts, and so on, and so on. And you're using one vehicle as possibly a vehicle as a pusher to push things along. You see what we do. This is how we do it. And then we try and separate the ferrous from the alloy, stuff that goes to landfill and dealing with the nasties like acid. And so progressively it goes on like this. So you'd have to do a bit of preparation of the site. So you'd have some places where you could put skips for transport and loading into rail wagons like that. And these are just pictures of sort of familiar vehicles which have got off the web. So you need a big skip lorry. You need a dock arrangement for tipping ferrous scrap into rail wagons, like that. You need other capital equipment. You need trucks. You need locomotives. You need cranes, skip trucks and skips and cutting sets. Lots of cutting sets. And a tanker each for spare diesel, another oil and assorted hand tools. All this sort of stuff, familiar things. Gas supply, a lot of gas. Oxygen and acetylene for doing the cutting. Assessed how many cylinders we need and the rate of consumption per month. So we then had a spreadsheet with base assumptions, variable costs, capital costs, income and outturn. The outturn, is it going to be worth doing this for somebody? So we've had these basic assumptions, number of vehicles, man hours per tank, productivity, with respect to the check estimate, because we reckon that probably, you know, that the labour force out in Kazakhstan would not be as good as the ones in Czechoslovakia. How long it would take, and all this, pretty obvious sort of things, really. Oh gosh, yeah, scrap metal, ferrous per vehicle in tons, rail wagon capacity. Just you've got to look at all this. Price of scrap steel per ton at the steelworks gate. That is absolutely key. So we had numbers as realistic as possible, and it looked on the model that we did. Now all these numbers are completely up the pole now. You know, this is 16 years ago. So some of these will have gone up dramatically. Some may have gone down, like the price of steel scrap. I mean, I couldn't say right now. I've not done any research on the back of this. But there would be an income of probably that from the activity and a break even of about 5 million quid, euros, rather, which of course is, well, peanuts, quite frankly. So is it worth doing? Now, I have to say I was, after we considered some of the outstanding issues, we concluded that probably it might not be viable. And a lot of things were left out, like cost of landfill and dealing with radioactive things, some of these things. We didn't even attempt to cost that. So we thought it's viable on the assumptions. They need checking, local numbers need putting in. It looks an attractive proposition, maybe, as it stands, but some outstanding issues need to be resolved. Now, let me just tell you before I get to the denouement, I think my last slide is coming up in a minute or less. I really fancied if I could have obtained permission from my local domestic management, which might have been a bit of a problem, I quite fancied going to Kazakhstan for a sort of sabbatical of 2 or 3 months to help with others in the team to put together and commission a train. Now, nothing has been mentioned about how all these operatives would live. And I had a vision of a train, literally a train, not just a train to deal with all the hardware, but one that would provide accommodation. So you'd have sleeping quarters, you'd have a kitchen and eating facilities, you'd have maybe an entertainment coach with a bit of a cinema at one end and all this sort of stuff. You need to be able to keep these guys motivated, you know, for quite an extended period. And that would have been another cost, which of course was not included. So I have to tell you that so far as I'm aware, I did check this out if Andy Shaw knew anything from Shrivenham, which is where effectively this was managed from at the time, if he knew what had happened to all this. Well, of course, he wrote a paper on it, which was published on the website at Shrivenham. But we have no idea what actually happened. I have a strong suspicion that nothing happened at all, and that all these things are still there, or probably in many cases. And we just thought, well, you know, the technology is fairly straightforward. The logistics are feasible. The economics is possible. the politics, well, the ethics, I don't know about that. That would be a good thing to do. But the politics would probably be the stopper. This is probably how you couldn't get it going. So in my opinion, the greatest challenge and probably the stopper in any circumstance would be the politics. And so, well, that's me. If you'd like me to give you a little preview of something I might do later, and that's how I ended up in Moscow, I could do that if you want. But any questions, as they say, I'll try and do my best. I don't know how big the audience has got to at this stage.